Welcome to a new episode of Playing with Junk. This time, as always, I have something special for you. It's a medical device from 1954 and it is called the MyoDynaFlux. It's a device that comes from France, so everything is written in Français, but that's not a big problem to find out what it means, so it's very logical. Now, what is it? It took me a while to find it out because it came from a colleague of mine and he found it in the attic of his parents' house. And on first sight, I thought it's something like the Mora machine, something esoteric, voodoo stuff, but it seems it is really a serious treatment device. It is used to stimulate muscles with electric pulses and electric currents. From what I found is it was used for people with that are disabled to prevent their muscles to shrink, or it was also used, maybe it's more a bit of beauty surgery to reduce fat, because if you make the muscles move by applying electricity to them, well, you also lose fat because it's burned by moving muscles. By the way, the name MyoDynaFlux, myo means something with muscles, dyna comes from dynamic, movement, whatever, and I guess flux comes simply from the electric current that flows, and yeah, I think that's about it. These two pages here, that's the only information I found in the internet. It's from some old publications from the 1950s. Maybe if I zoom in, you can probably read it. So the first is a general discussion about electric currents of medium frequency. And the second part is a description of this apparatus here, the MyoDynaFlux from Dr.Djourno, and there's also a picture of one of them, so it seems there have been different versions. So for example, with this drawer base, there's also a short explanation of the impulses that the unit generates, for example, the increasing periods, the decreasing, the rest time, the pause between impulses and all that stuff. We will see that later when I turn it on. Dr. Djourno or Dr. André Djourno was a French doctor who experimented with all kinds of electric stimulation of nerves, and he was one of the pioneers who invented the cochlear implants. That's an artificial hearing aid that connects directly to the hearing nerve, something that's quite usual today, but it was absolutely pioneering in the 1950s. But my machine here has nothing to do with that. Okay, let's stop talking, let's turn it on. That's the mains plug. I have never seen one of this before. It's a 4-pole plug, but 2 poles are ground. Then phase neutral. The machine can be set from 110 to 240 volts. And I plug it in now and turn it on. So the first moment we have to wait until the radio tubes get hot. Yes, it has tubes inside, or valves, however you like to call that. Okay, let me see. So, of course, I don't want to connect myself to this machine. That seems a little bit dangerous, but I have a small speaker here. Let's see, intensity is 0. And let's hear what comes out of the machine. So we have this knob here set to MF pure, that means medium frequency. Medium frequency in this case means we have 5 or 10 kilohertz. That can be switched here on the side, 5 kilohertz, 10 kilohertz. Maybe hertz it's the right name in this way, because it probably hurts if you turn the intensity too high. It could also induce some headache if you listen to that too long. So now you hear a 5 kilohertz sound. It's pure medium frequency, or 10 kilohertz. And I measured it before with my oscilloscope. It's bang on, 5 kilohertz, 10 kilohertz. After 30 years in an attic with all that dirt and stuff around, that's amazing. Okay, then we have short periods. So this lamp goes on, that means this circuit here is active. And you can see it on the needle. We have short pulses of 5 kilohertz, and we can make them faster. So we have approximative per second 50 impulses of 5 kilohertz signals. We can also set long periods, and then this circuit here is active. You can see the red light here. That means, and this is simply a flip-flop circuit, an on and off circuit. It means work and break in between. And here we can set the seconds, how long this work or break periods are. So 3 seconds, 3 seconds on, 3 seconds off, or 6. And then we have another knob here. Here we have a 1-to-1 ratio. That means work and on and off periods are in the same length. Or we can set it to 1-to-2. Well, that isn't exactly working, but it makes longer stops and only short working periods. So maybe we have 2 seconds on, 2 seconds off, 1 second on. More or less it works. And here, of course, is the intensity or volume knob in this application here with the speaker. And we have a third or fourth setting, so all three lamps are now on, and we have the short periods and the long periods, and you can hear the result. Yeah, it's a nice thing to play with. Let's turn it off. I'm not sure how patients reacted to this contraption when they have been actually connected to that. But from what I read in the papers, it is more or less painless because of the higher frequency. So in the early days they made it with DC, with AC, 50 Hertz, 60 Hertz, and that was most likely more painful. And well, I don't know. Let's see inside. The cover has 4 screws, and when you remove that, you can easily lift off the entire cover. They made an extra notch here, so that the side, the button on the side can slide out without being removed. You can also see here, it is written 5 kilocycles and 10 kilocycles, cycles per second, not hertz, cycles. And that's the apparatus inside. Of course, it didn't look like this when I got it. It was totally dirty and dusty, and I had to clean everything. But besides of cleaning and a little bit of repainting the cover, there was no defect, in fact. It had a little problem. When I first turned it on, it worked for about 1 or 2 minutes, and then it suddenly stopped working with a little tick. And well, I thought, yeah, maybe one of the parts here has a thermal problem. So the next day I turned it on again, and it worked for 1 or 2 minutes, made tick and went out. And then I started to tap the tubes a little bit, and when I tapped this tube here 1 or 3 times, it suddenly started to work again. Then I let it cool down. It made the same error again. After 2 minutes it went out. I tapped the tube, it came on again, and since then it's working. I don't know what happened. Maybe it was a little bit dirt or corrosion in the tube socket, but well, maybe, or the tube itself something was broken inside and it welded together when I tapped it, or I don't know what happened, but since then it's perfectly working. Okay, let's have a look what we have here. First of all, there is the voltage selection connector, and this connector has quite an interesting feature. If you look closely at it, you will see a very fine wire between the two plugs here. And if you look even a little bit closer, oops, where is my camera? You can also see a marking saying 3A. That's a 3 amp fuse. And if the fuse blows, you just screw out these pins here, and you replace this fuse thing. It's just a flat piece of insulating board with some plastic over it to protect this thin wire, and that's the selector plug with integrated fuse. Very interesting. I put it back on 220 volts. That's correct where I live. Then we have two tubes in a, oops, sorry about the shaking, in metal cases. The first one, if I remember right, is a rectifier tube. It's just like a bridge rectifier, but in form of a tube. The type is 6X4. Then the OA2 tube here is a voltage regulator. It regulates a voltage of 150 volts, fixed. You cannot change that, but I think that may be used for the smaller tubes that follow here. The 5Y3 is, what was it? I think that was the oscillator tube here. These two are 12AU7. So all the tubes have different, no, I have to say it differently. You can have the same tube with different names. For example, 12AU7 is a typical American kind of naming. The European equivalent to this one would be the ECC83 or 82. Well, there is a European name designation and an American, and the Russians have another one too. But sometimes you can replace one with the other without problem. You just have to compare them. Because a triode, a small triode, is a small triode, no matter where it is manufactured or not. And I think the two here, because there are two identical tubes, are for the flip-flop, for the lights, for the on and off switching circuit. This one, the 6SN7, is mostly used as an oscillator tube, so this is probably to making the 5 and 10 kilohertz signals. And at the end we have a 6L6, that's an end tube, a power amplifier tube. It has an output of maximum about 30 watts. And the funny thing is, this tube is still manufactured and quite widely used in guitar amps. So tube guitar amps are still manufactured. These tubes are still manufactured. Some come from Russia. I think the 6L6 would probably also be manufactured in the US or wherever. And they are still used in guitar amps because guitar players love the sound of tubes, because when you play an electric guitar, you want your amp to distort the signal. You turn it up until it clips. And tubes have a very distinctive way of clipping the sound. So it sounds nice. A transistor circuit will sound quite hard and harsh, and I can show you that. So let's say we have a sine wave and we go into clipping, so this part will be clipped away. But I have to go a little bit closer. So a tube will clip it this way, while a transistor circuit clips it in this way. So you see here we have a very sharp edge, and that's the tube edge. This is more like a square wave, and this is something between a sine and a square wave, and this sounds definitively better. Of course, with some additional circuitry, with transistors, you can also simulate this curve, but yeah, the real fans like tubes. By the way, we also have 4 lamps here, small incandescent lamps. From what I saw from underneath, which I show you just a little bit later, these 2 are just spare lamps, they are not connected. So even if we remove them, nothing else happens. But these 2 are connected, and they somehow go to this rectifier and voltage regulator tubes, and I assume probably they are made for inrush current limiting, or well, maybe one of you YouTube fans, YouTube fans, you probably know that better. I'm not a tube circuit specialist. But, well, let's have a look on the bottom part, which is quite interesting and nicely made. Just have a look at this, isn't that beautiful? And the best part is I haven't changed anything. I only put a drop of oil to this switch construction here because it was going a little bit hard. So it needed a little bit, a drop of oil here and a drop of oil here, and it works like new. And all the rest was just as it looks now here. No dirt, no dust, no nothing. Everything in perfect order. Here you can see the sockets of the light bulbs. They are not connected. No connection here, no connection here. It's just a spare a holder for spare bulbs, and then we have one here that has connections, the blue ones and the red ones, and they go to this rectifier tube, the red ones, and the blue ones, well, they go somewhere else. I don't have a schematic diagram, that's too bad, but well, it would be possible to draw one, but hey, it's working and everything is fine. So what's a little bit funny is here this switch, they mounted it here instead of directly mounting it on the frame. But I think that's because the main voltage cable comes in here, and that was probably too close to that switch. Who knows? So they decided to put the switch a little bit further back and add this joint here, this flexible joint, because it's a little bit off the angle, but it's working. And I think that's one of the switches you didn't use too much, too often. Okay, that's it. And now I show you some pictures from the restoration process without words. Thanks for watching.